do a solution walkthrough of this problem number 3, which is using a simulation to approximate the probability of avoiding the origin on an n-step random walk in 2 dimensions. So I've really been emphasizing trying to decompose the problem into separate methods like this. And it might make more sense to you to start with the code that actually generates the table, or it might make more sense to you to start with the thing that's the most immediate. How do you actually simulate the n-step random walk? But either way, instead of just sitting down to code line by line, you want to really make sure that you can imagine how these pieces are going to fit together before you start coding, and then fill in sort of from the inside, as it were, fill in the middles of the methods. So let's start explaining it maybe backwards from the actual method that simulates the walk. So I know I'm interested in simulating an n-step random walk, and this is the method that's actually going to do that simulation. So because it's an n-step walk, I need to take a parameter that's the number of steps, and my walker is going to start at the origin. And so then I'm going to loop exactly how many times I need for that number of steps. And at every loop, I'm going to generate a random number, which is going to add or subtract 1 from x or y. So that's how I'm going to decide to step. All right, so I'm walking and I'm walking and I'm walking. And the question is, what do we want to know eventually from this random trial? Like, what do we care about the walk? And the answer is, we want to know what's the probability of them avoiding the origin. So if we step back up here, this is the method that's actually going to run that simulation a whole bunch of times and then use the results to calculate what we care about. So if I'm looping for a whole bunch of different trials like this, and I run each trial, if I'm going to calculate the probability of avoiding the origin, I need to know how many times did I actually avoid the origin. And so I'll count those, and then I'll divide by the total number of trials, and that will give me an approximation of the probability. So what that means is this method that actually simulates the random walk should return whether or not we successfully avoided the origin, because that's the piece of information that this other method is going to need in order to calculate the probability. So I'm actually, I phrased this carefully. So I named my method avoid origin on random walk. So if we return true, that means I avoided the origin. In other words, I never went back to the origin. If it returns false, that means I failed to avoid the origin, or in other words, I randomly touched the origin. So as I'm walking in this for loop here, if x and y are ever both equal to 0, that means that I have returned to the origin. And notice I'm doing this test only after I've taken my first step, so that way I don't accidentally detect myself at the origin right when I start. So I've taken my steps. If I ever touch the origin again, I'll immediately return false, because at that point I know that I've failed to avoid the origin, so I don't need to do any more steps. I know the answer is no, I didn't avoid the origin. Otherwise, you can take the rest of the steps, and at the end, if I never touch the origin, I know I avoided it, so I can return true. Okay, so going back up a level now, we were calculating the probability of avoiding the origin, so I'm looping over a whole bunch of trials, and for every one I'm saying, if I avoided it, that's the situation that I want to count, because I want to know how many times did I do that divided by the total number of times. So I've got a counter to count it, and then at the end, I divide. The only thing to be careful whenever you're doing these is be careful about integer division, so that's why I cast a double here. Okay, a slightly better design for this, you notice I have this sort of constant, although I didn't even mark it final, called max trials. A slightly better design would have been to put that as a parameter for this method, just because that gives this method a little bit more flexibility. So if I wanted to, I could say int max trials up here, and then I would delete it from in here, which would mean that whenever I run get probability of avoiding origin, I tell it how many steps do I want to take in my random walk, and then how many trials do I want to use to approximate the probability. So here I am in my highest level method. This method literally just prints a table of results. So this is different numbers of steps that I might take, And for each number of steps, I run my method, which will calculate the probability of avoiding the origin for that number of steps. And then I print the number of steps, and I print the result. So that's it. And I realize that this is a lot to think about, and that's kind of the goal of these problems, is to give you a complex scenario where organizing it carefully is going to be required. It's too hard to think about if you try and attack it directly. Okay, so come back next time, and I'm going to walk through another problem. And the goal of doing these problems from scratch is you want to be able to successfully decompose them and imagine how all the pieces fit together yourself before actually starting to code. So we'll work on that next time.